Hi everyone. So today we'll be doing chapter A1.7, Humanitarian Applications. And just to reiterate, as many of the videos that I've made already, this is me just taking what authors have written in the book and explaining it to you in this video so that you have both a video application and your own independent method if you just follow the book itself. So we're going to go through chapter overview and a bit of the theory, and then we're going to get into the practice in the next videos. You can access the book through this link, and you can access the book itself through this link. This is going to give you the chapter in particular. So what are we going to do in this chapter specifically? The global refugee population has never been larger than it is today. And there's about 26 million refugees worldwide, living in more than 100 countries. And so, if we get our definitions right, what are refugees? As per what's written in the book, refugees are international migrants who have been forcibly displaced from their homes and their countries because of violence or persecution, and they're crossing an international border and settling elsewhere, most often in neighboring countries. So, how can remote sensing help in this case? Well, it's offering help to refugee leaders, humanitarian agencies, and refugee hosting countries by helping them gain new insights into refugee settlements, which is what we're going to be doing today, population and land cover change dynamics, which is also things that we're going to explore today. So, in this chapter in general, we're going to examine the value of using satellite imagery derived data to map a refugee settlement in Uganda. We're going to estimate its population, and then we're going to gauge land cover changes in and around the settlement. And that's going to help us delineate the settlement's boundary, which we're going to make comparisons with. So this, as always, every chapter kind of goes through this, but the learning outcomes, is going to be using a range of techniques. We're going to make a video time series. We're going to make some charts, some maps. And this is all to visualize and measure land cover changes before and after the establishment of a refugee settlement. We're going to understand the considerations and limitations that are involved in automated detection of refugee settlement boundaries through an unsupervised classification. And then we're going to become familiar with satellite-derived human settlement and population data sets and their application in a refugee settlement context. So this is all in the slide. And again, I invite you to go to the slide just to see what we assume you to know. I'm not going to go through all of this, but basically, for these applications, it's really important for you guys to go through chapter F1, F2, F3, F4, and even F5 because there's a lot of reduction functions. And so this is just what it's saying. This is assuming that you know the basics of Earth Engine and you've gone at least to chapter F5 to know your applications. And this is functions, image collections, importing images, basic image analyses. We're going to add names to bands. We're going to add extra bands. And these are all things that I'm not going to go into detail with. So it's important that you know it beforehand. So before we get into it, we're going to give a bit more context too. So in our chapter, we're going to document refugee settlement dynamics through the analysis of multi-date Landsat imagery. And this is something that is widespread and can be done. These are images in the book itself, and they're basically maps of a UNHCR refugee settlements in Uganda. So that's the United Nations High Commissioner for Refugees. We've got the OSM features, the roadways, and then the UNHCR settlement boundary here. And then in here, you've got the European Space Agency 2020 World Land Cover at Pagirinia. I'm sorry if I'm mispronouncing that. So in a humanitarian context, remote sensing data and analysis, like I mentioned earlier, have become essential tools for monitoring refugee settlements and their dynamics, both after refugee arrival and over the long term. And we're going to do before and after in our analysis. And even with that, however, as all technology, there are still important challenges to characterizing refugee settlements conditions. And this is because first, dwellings, roadways, and agricultural plots will often tend to be small in size within those refugee settlements, and it becomes difficult to detect without the use of very high resolution satellite imagery. That in itself costs a lot and requires very high tech um, components. So it comes with the budget that you have in terms of what you can do. And then dwellings and other structures in those refugee settlements can be diffusely distributed and intermixed with vegetation and bare earth, um, as said here. So these are the three challenges. And this again is going to be confusing because when you're dealing with remote sensing, it's very important when you're trying to determine land cover types and you're trying to determine what the land cover is and trying to determine your settlement boundary. There are some components that will come up based on their spectral indices that might be similar, and that just makes the change detection difficult. And that's why, again, you'll want something that's more high tech, high resolution, but that in itself is hard to obtain. So then the last point is that data on settlement features, boundaries, and refugee populations are often out of date, or otherwise they'll be inappropriate for detailed geospatial analysis. So in this chapter, we're going to address these challenges using multi-date Landsat imagery to document settlement dynamics. And so these are just example of what refugee settlements might look like. But when you're sharing a very large boundary like that, they can go for very long distances. So just note that this is the abbreviation that we'll be using. So the UNHCR, the United Nations High Commissioner for Refugees. So before we go into the practice, you can access the book scripts in G. You've got the code editor here, and you've got the book scripts, all available in the slides. So let's start with section 1. We're going to be seeing refugee settlements from above. This is kind of the basics. This is where we'll also create a video, and we're going to use the imagery to characterize initial land cover conditions and land cover changes at Pajarinia refugee settlement in the years before and after 2016, which was when the settlement was established. And in preparation for the arrival of refugees, humanitarian actors and refugee settlement planners are usually interested in analyzing the local land cover because you want to detect the conditions that are there before a refugee settlement is established. And so in this section, we're going to use the Landsat satellite imagery, like I mentioned, to characterize the initial land cover as one would do before the arrival of refugee. We're going to create a frequency histogram for pre-establishment and post-establishment. We're going to create an image collection with indices like the NDVI, NDBI, and NBR, like the ones you should have seen in previous chapters. We're going to do some clipping, visualizing the composites, and then we're going to build the composites and make a quantitative assessment like this. We're going to create an annotated video time series. We're going to rename some Landsat bands, and we're going to filter the collection to the buffered settlement. So first off, what we're going to do is you're going to go in checkpoint A, and you're going to copy into your own script so that we can start. Okay, so let's start looking at the code. So first things off, we're going to be adding the settlement boundary for Pagirinia refugee settlement. I think I've used to say Pagirinia. I think it may be Pagirinia, but again, if I'm saying it wrong, I apologize. So we're going to add the refugee settlements boundary to the map by loading it from the feature collection. Now, in this case, I'm not the one that wrote this code, but this would be from the creator's assets. And so you would just, because we've copy pasted, you have it already. And we're going to be looking at the refugee settlement boundaries in Uganda, and we're going to filter it to Pagarinia refugee settlement. We're also going to center it, and we have our variable that we're going to keep calling often. And then we're showing the satellite base map for visual reference. Again, for Pagarinia, we have the location, but we're also going to create a buffered settlement boundary geometry within which we're going to be working. We're going to use it several times for spatial filtering and clipping because that's our general area of interest to work with. We're going to do 500 meters, and then we're going to create our variable buffered bounds. That's going to pair it with our geometry. So once that's set, we have this set, we're going to use it later on. Then once we've done that, we're going to create annual Landsat composites using the Landsat 8 surface reflectance image collection. So that's down here. What's happening up here is the function that we're going to create for our indices. Because basically, while this is first in the code. It is later down in the book, but you've already seen this in chapter F2. We're gonna, so I'm just gonna gloss over it. But first, we're gonna rename our Landsat bands. So we've got our Landsat 8 band names that are the usual that you can find in the metadata, and we're going to rename them based on what they are. It's just easier to read and add. And we're going to add three new spectral indices to each image using the add indices function. And we're going to look for NDVI, NDBI, and BR. We're going to use the normalized difference function, which is an Earth engine function. And then you can add the bands to your IMG, which is your image here. So once that's set, you can do also map at indices. So you're kind of just setting your functions beforehand, but it is technically later in the book. So in this case, we're going to spatially filter our image collection to the buffered settlement right here with the buffered bounds. And we're going to temporarily filter it from 2015 to 2020. And that includes the full year before the settlement was established and the 4 years that followed. Remember, post 2016. And then we're also applying a cloud cover filter, them of less than or equal to 40%. And that helps us ensure that our annual composites are cloud free, or at least most of them. After that, once we've renamed the bands, we've added our indices. That's all in the first section. We're going to make our annual pre and post establishment composites. And so just to reiterate here, the reason that we're adding these indices is because, again, in this first section, we're going to be looking at the land cover conditions, land cover changes. And so this just offers a different approach to characterizing land cover conditions and change over time. NDVI, for example, is known, as you've seen from previous chapters, to be used for monitoring vegetation health. You've got then NDBI that helps to characterize impervious and built-up surfaces. And you have NBR that helps to identify land that has been cleared with fire, because that's the normalized burn ratio, which is a common practice in this region that we're studying in Uganda. For this specific region, we're doing this, but you may be looking at other spectral metrics that are better suited for identifying refugee settlements in other regions if you are to replicate this type of code for your purpose. So to make our annual pre and post establishment composites, we're going to build it from before and after Pegarinia's establishment in 2016. Hence why we're just working with 2017 here, not 2020. And we're going to create two temporal subsets of the image collection that we have here. And we're going to use the median function to composite those images for each time frame. So again, remember, we're clipping to the buffered bounds, and that's our buffer that we had just created. So as I mentioned, this is going to be used often. And image indices is what we're going to be using if you add our indices to this collection. So then our next step is going to be to, after clipping our image collections, we're going to visualize the NDVI composites as a true color and a false color visualizations. And we're going to be using palettes from this GitHub link that is provided by the creator. And so we can look at it, but I really invite you to go look at it yourself with the metadata, because it is interesting to look at. It gives you a bunch of different color palettes and information about what to do with it. And I think it's interesting to find new resources that can be used in Earth Engine. So this is a module for generating color palettes in G. This is how to add the module, how to use. So if you notice, this is what's happening in this script. We're doing what they're asking. And then to define a palette, we're doing that here. So we're defining our green palette and our PR green palette. And then we're just following the code that GitHub is giving us. So that's what's happening here. We're setting our true color and our false color visualization parameters. And so the true color is just going to be RGB, and then the false color is going to be NIR, red, and green. Then you want to display, so we're just doing the map add layer with the variables that you've set early on. So pre-median, post-median here, and then vis-param in those cases. And then you're going to display it, and I'm going to run everything all at once. And so far, doing so just helps us identify and interpret features within and surrounding the settlement boundary. And so that's really what we're focusing on in this section is understanding what the land is like for different time frames. So then we're going to display median and DVI composites specifically, because here we have the pre-median and post-median. It's just the image in general. And then in this case, we're going to look at the NDVI composites directly just to have different visualization parameters. And this is just an addition, like a complementary quantitative assessment that we're going to do by measuring pre and post establishment differences in median NDVI and plotting the distribution of NDVI from both periods. So what we're doing here is actually going to be helpful for the chart that we're building here. That's why out of the blue, there's some median NDVI composites. So you're just adding that to the layer. And then we still have our settlement boundary that we want to add on. So we're going to create an empty byte image, and that's going to allow us to paint the settlement boundary on top of it and overlay it. So we have our feature collection Pegurenia, and we can put our boundary in blue. And so on top of the images that we're going to have our settlement boundary. So these are the layers that we're slowly building. And then we're going to compare the pre and post establishment differences in NDVI. As I mentioned, this is the median NDVI. So we're going to subtract the post from the pre-median. We're going to select specifically the NDVI bands, and that's going to give us the difference between pre, which is 2015, and post, which is 2017. And then we're going to chart those NDVI distributions for pre and post establishment. So you've got here the NDVI and then the pre-NDVI, and then you've got the NDVI and post-NDVI. So it's here, and you're just naming it here. So you're selecting and then you're naming. And then we're going to build a frequency chart because we're just looking at building a histogram from pre-establishment to post-establishment, looking at NDVI. And that's what we're going to print first, because the next part is going to be making our annotated video. Now, this chart you should have seen in other previous chapters. Building charts is something we do a lot beforehand. So this you should know what's happening here with image, region, buffered bounds, our names, the title for the histogram, what we're counting, the colors, one for the pre, one for the post. And then we're going to have our pre-post NDVI frequency chart. And again, we're working with the median that we had created earlier. So then before I run everything, we're going to create an annotated video time series of the full 2015 to 2020 Landsat 8 surface reflectance image collection. So that is our image here. And we're going to be able to use this video to look at the changes at our study refugee settlement image by image. So that's what this video is going to be looking like. So in this case, you are importing the package. Again, this is based on what the creator is importing it from. So if you're copy pasting, you'll have this information. Just gonna post this. You've got your RGB bands, just for a true color image in the video. You've got your video arguments. So again, your regions, how many frames per second. This comes with the function as you're building your video. Annotations, where do you want them? And then you're doing the add text function because you want to add the dates for each image that you're looking at, which is in this format. You then want to add your image, clipping it to buffered bounds, visualizing with the RGB parameters that we put here. And you want annotation. You want to create an image with the label overlaid using Jenna's package. And this is the Jenna package and that you had imported. And then here again, you're annotating your image, buffered bounds annotations. Then you're adding your timestamp annotation to all images in the video using ICMap. And then we're printing it. And this is with the get video thumb URL function because we're going to get an URL that we can then open in a new tab. So when looking at these graphs that are popping up here, higher NDVI usually will mean, like here, let's look at it. So NVIDIA value should range between, I believe, 0.2 and 0.5. And so the higher NDVI values will usually mean denser vegetation cover. And as you can see from pre to post-establishment, we're looking at a decline in NDVI values and as well as in frequency. So that could mean that with the establishment of the settlement, we've lost NDVI values because we're looking at an area that's been used for building. But we're going to learn more details about that. So let's look at our layers. So these are all the layers that we've built. Let's just go one by one. So we've got the refugee settlement, the boundary, what we did at the start. We've got the pre-established median, post-established median, and this is just this is our true color composite, and this is going to be our false color composites. So this is because we are changing our visualization parameters. Now, the false is going to show vegetation. This is the post, and then this is the pre. Dark red, red in false color will mean vegetation and at different degrees. And if you compare with the chart here, we're looking at the NDVI. Post, you can see that there is some loss. And so that could make sense with the NDVI frequency histogram that we're seeing here. And we had built that here when we did the median NDVI composites of pre-establishment and post-establishment. So these are our medians. So here you can see the pre-establishment NDVI, and then you've got post-establishment. So there is a difference, and we see that as well with the quantitative assessment that we did to add on to the visual observations we were looking at right here. Again, this is what we did with the paint. So we had the settlement here, but with paint, we were able to draw the boundary and overlay it. So when I'm looking at, for example, these establishments, then I have it overlaid. And this is going to be useful for the video as well. And then this was our difference median NDVI, and this is just allowing us to see the changes that have happened because you're calculating the difference between these two. So this and this. Okay, so now we have the URL as well for our video, and we're going to look at what's happening. So remember when we were making the video, we had dates on the left annotated because this is an annotated video. We've got our boundary. And here, really what we're doing is simply creating a time series video of the image collection that we have from 2015 to 2020. So you've got really just your annotations and your buffered bounds because you want a specific area that you're looking at. So in this case, it's our, if you remember, our settlement boundary. And you can see the change that's happening over time with the video of the images. Just a different way of visualizing information and viewing changes of our study refugee settlement image by image. So now we're going to go to section 2.